we start with a circle, and the circle that we see has this inscribed angle, and it has this central angle right here, and both those angles subtend the same arc. And the problem is to find this angle. So this is the inscribed angle. Now, in the problem, we don't have the value of the central angle right off. What we have is the value of this angle over here. So I'm looking at this, and the first thing I realize is that, well, if this is a central angle, that means that both of these lines are radii. So it means that this line and this line are the same length. They're congruent lines, which makes this triangle an isosceles triangle. If that triangle is an isosceles triangle, then that angle over there, 50, is also equal to this angle. So this angle is 50. And if we know that the sum of the three angles in a triangle is 180, 50 plus 50 plus this angle is 180, that means that this angle must be 80. Okay? So if this angle is the central angle, okay, this angle is the inscribed angle, that means that the inscribed angle is equal to the central angle divided by 2. 80 divided by 2 is just 40. So we find that x is equal to 40 degrees. Let's look at another problem. Let me pull that problem right up here. There we go. We have two chords intersecting in a circle, and they form this angle right here, which is 53 degrees. And the intercepted arcs, here's one intercepted arc, is 10x minus 14, and the other intercepted arc is 3x plus 3. Now remember that intercepted arc, the measure of the intercepted arc is exactly the same as the measure of the central angle that this arc subtends and this arc subtends. And but this angle right in here is not a central angle because it doesn't have a vertex at the center of the circle. So we have to do something else with this problem. So let me begin by adding an extra line, and I'm going to add this extra line right here. Oh, I don't want to do that. Undo drawing. Here we go. Add extra line right here. So I add this extra line right here. So now this is an inscribed angle right here, and the inscribed angle intercepts this arc. Okay, so that means that this angle right in here is half of the central angle, or half of the intercepted arc. So this angle right in here is 3x plus 3 divided by 2. This angle right in here is also an inscribed angle, and this is the intercepted arc, or in other words, this is the central angle for that inscribed angle. So this angle right in here is half of that. So that angle right in there is 10x minus 14 divided by 2. This is this angle right in here. Now this angle, so we're getting the three angles for this triangle right in here. This angle is going to be 180 minus 53. So this angle is 180 minus 53. So we now have the three angles for this triangle, boom, 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 like this triangle. We have those three angles. We know the three angles of a triangle must add to 180 degrees. So we immediately see that this angle plus this angle plus this angle equals 180 degrees. So I want to solve this equation for x, and then I want to evaluate this and this to see which one is larger. I subtract 180 from both sides, so this cancels. This cancels with that. I add 53 to both sides of the equation. So I have 3x plus 3 divided by 2 plus 10x minus 14 divided by 2. Add 53 to both sides means this equals 53. Now I'm going to multiply both sides of the equation by 2 to get rid of this denominator down here. This gives me 3x plus 3 divided by 2 plus 10x minus 14 divided by 2 times 2 equals 2 times 53. Okay, now I multiply here, this cancels with that. Multiply here, this cancels with that. So I get 3x, sorry I forgot the x here. I now have 3x plus 3 plus 10x, oh I forgot the x here too, 10x minus 14 equals 2 times 53, which is 106. 106. 3x plus 10x is 13x. 3 plus a negative 14 is negative 11. So I have this equation. Add 11 to both sides. I get 13x equals 117, or x equals 117 divided by 3. X equals 117 divided by 13. Okay, well, you crank this out and you'll see this is equal to 9. So x equals 9. So if x equals 9, then 10x minus 14 is 10 times 9 minus 14. Okay, this is 90 minus 14, which is 76. 70. Okay, now this angle is 3x plus 3. And 3x plus 3 is 27 is 30. So it looks like this is the larger angle, 10x minus 14, and this equals 76. Okay, let's do one more problem. This problem right in here. A cathedral window is built in the shape of a semicircle. If the window is to contain 3 stained glass sections of equal size, what is the area of each stained glass section? Express your answer to the nearest foot. Well, we have a semicircle, and with the semicircle we have that the diameter of the circle for that semicircle is 5. So the radius of that circle is 2.5. So you immediately know the radius of the circle is 2.5, 2.5, or that's equal to 5 halves, right? The radius of the circle is 5 halves. The area of the circle is pi r squared. So area of a circle is pi r squared, which is 5/2 squared. And the area of the semicircle is a half that. So semicircle, I'll just write semi-area, is 1/2 times 5/2 squared times pi. Okay, let's evaluate this expression. This is 1/2, okay, 5 squared is 25 divided by 4 times a half. So I get 1/2 of 25 divided by 4 times pi. This is equal to 25 over 8, because 2 times 4 is 8, times pi. And the area of each segment are equal. So each one of these is a third of the area of the semicircle. So the segment area is 1/3 of this. So it's 1/3 times 25 over 8 times pi. And that's equal to 25 over 24 times pi. Okay, now they want the answer to the nearest square foot. Okay, so we'll do some approximations here. 25 divided by 24 is approximately equal to 1, and pi is approximately equal to 3. In fact, about 100 years ago, the Indiana state legislature tried to legislate the value of pi to be 3, so you didn't have to remember that irrational number stuff. So this is about equal to 1, this is about equal to 3, so this product here is about equal to 3. So the answer is, let's say to a nearest foot, if this is 5 feet, the answer to the nearest foot is that the area of each segment is equal to 3 square feet. Okay, until next time.